So let's suppose we've got this Dijkstra graph here. We've got what 1, 2, 3, 4, 5, 6 points and a few vertices in between them. Or sorry, these are the vertices. And we've got edges in between them. And we want to find the shortest path between A and F using the algorithm. So I guess let's get right into that. The first thing we need to do is make our unvisited set. So we'll just call it U, unvisited, right? And that's going to have all of our letters, A through F. A, B, C, D, E, and F. All right. Line that. And now we need to assign distances for all of them. So we'll say distance. And so A is our initial node, and so that distance is 0. So we're just going to put a 0 there. And everything else we haven't checked yet, and so we're going to initialize it as infinity. So each one of these has a distance of infinity because we don't know what it is. We haven't checked it yet. And now we can kind of start iterating through this algorithm. A is our current node because it has the smallest distance. And since it has the smallest distance, we want to look at all of its neighbors, which is B, C, and E. So B's distance from A is 5. So let's change our color for each step here. So B, its distance is 5. So that means we're going to cross this out because 5 is less than infinity. And then C's distance is 1, which is less than infinity. And E's distance is 4, which is also less than infinity. And now we've visited everything that we can from A, and so that means we can remove A from our unvisited set. A is removed. And that was a little over dramatic. There we go. Now let's change our color here to a nice green and look at the next lowest number, which is C, right? C has the lowest distance. So let's look at all of C's neighbors. So we don't go back to A because A is no longer in the unvisited set. But we can look at B, and the distance to B from A going through C, so this distance here is 4. And 4 happens to be lower than the current distance, so we're actually going to cross that out, and we're going to change that to the new distance of 4. And now let's look at the next neighbor, which is D. And so the distance to D from A going through C is 3. So we can change D's distance to 3. And last, let's look at C to E, and that distance is 3. And we had it at 4, which 3 is smaller, so we're going to update that to 3. All right. Now let's remove. We're going to remove. Oops, I should go back to my green real quick. Remove C because we visited everything we can from it. And we need to look at the next smallest one, which in this case is D. And D's got a value of 3. E also has a value of 3, so it doesn't really matter. In this case, we'll just pick the highest, or the first one on the alphabet. So D's got a value of 3, and let's look at its neighbors, which happens to be F and E. So F has a distance of 6 from D to F, and we add on the rest of the path, which is 3, so that gives us a value of 9. So we can cross that out and put a 9 here. So we have reached it, but really with our algorithm we want to fully see this through here. So we've reached F, but let's look at the other neighbor, D to E, and that's a value of 8 plus 3. So that's 11. And E already has a lower value of 3, so we're not going to add that 11 on there. We always want to keep the smallest one. And so that's all of D's. Oh, we also have B. So if we go from A to C to D to B, that is 3 plus 3, which is 6, which is higher than this value. So that's we're also not going to update that. And that's all of D's neighbors. And so we can remove D from the unvisited set. Now let's go with the rich blue here. And now we want to look at the next lowest one. So even though we found F, we can't stop yet. We want to always go with the next lowest path, in which case that's E, and it's got a value of 3. So let's look at E here and see what we've got. So E has a neighbor of, well, we're not going to look at C. We're not going to look at D. We're only going to look at F. And so going from E to F, that's a value of 7 plus the rest of the path, which is 3. And so that makes F a 10, which we're not going to update that. And so that's the only neighbors that E has. So we didn't really get anything there. We're just going to cross off E. And now our next lowest value is B, right? And B has a value of 4, and we see F has a value of 9. So if we look at B, all of its neighbors are already visited. So we can actually just remove this guy. We've got nothing to actually check there. And so that means we're kind of done with, we've got F here. And then we can just kind of trace back, right? So we've got, obviously we've got F, and then the next lowest hop, right? We're going to D, and then C, and then A, right? So this is the path that we've found.